For our last problem in this section, we're going to take a large corporation that has 1,500 male employees and 1,200 female employees. And a survey found that 40% of the male employees and 30% of the female employees have hypertension. One employee is selected at random. So we got to find probabilities. So what we need to do to make life really easy for all of the questions being asked is draw one Venn diagram that describes this problem. And notice we've got some percents and we have some numbers. So we're going to have to decide whether we want to go percents or numbers. And I think I'm going to do numbers. For numbers, how many elements are there in the sample space? How many employees are there? 1,500 plus 1,200 is 2,700. That means all of the regions inside here have to add up to 2,700. Let's see. Let's figure out what these percentages means. A survey found 40% of the employees, of the male employees, 40% have hypertension. So 40% of 1,500 is 600, because 4 times 15 is 60. So 600 male employees with hypertension. 30% of the female employees have hypertension. 30% of 1,200. 3 times 12 is 36. That's going to be 360 female employees have hypertension. Okay, so what I'm going to do is I'm going to draw one circle. I really could do it like I did in a previous video. I was going to draw one circle for male and one circle for not female, but hypertension. That would work fine. The reason I'm not going to make two circles, one for male and one for female, is there's no intersection between those two, right? And then it could make our Venn diagram a little more complicated. So maybe I'm going to do what I said before. I'm going to do it this way. Male in that circle. So where are the females? Everything outside of the circle. You could say that the complement of M would be F. I'm not going to put F in here. I'm just going to make a note that these two things are equal to each other. The complement of male is going to be female. The other circle is going to be H for hypertension. And this gets us everything that we need. Let's first, before we move on, describe what all 4 of the sections mean. All 4 of these sections. Well, this circle is the male. The whole circle is male. This whole circle is hypertension. So what is this region right here? Let's do the intersection, the football region. The intersection, this is the male employees with hypertension. This is the male employees without hypertension. This is the female employees, not male, that have who have hypertension. And then this is the female employees out here who do not have hypertension. That's all of the bases covered. Because remember, everything outside the male circle is female. So if you're outside of the male circle, you're either in this or here. You either have hypertension or not. All right, let's fill the numbers in, and then all the questions will be very simple to answer. Okay, so we've got 2,700 total. All 4 of the regions have to add up to 2,700. What do we have? How many, let's do this innermost region first, the most overlapped region, which is this intersection. How many males are also in the hypertension circle? Males who have hypertension, 600. All right, and remember that the males, there are 1,500 total males, so I put my little cheat number in parentheses there. The male circle has to add up to 1,500, which tells us that what's this right here? 900. And then the hypertension, let's see, what do we have? 360 females have hypertension. So the females are everybody outside of the male circle. So these are the females with hypertension. These are the females without hypertension. So this is going to be 360. And that means that, how many do we have in the hypertension circle? How many total employees have hypertension? 670, 960. All right, so now, what number do we put out here? This is the females who do not have hypertension. So the females that do not have hypertension, we could just look at it and say, well, 1,200 female employees total. And the only region we have numbers in that are female employees outside of the male circle is this. So outside here is going to go 1,200 minus 360, which would be 840. Okay, so you should make sure you understand where all of these numbers came from, and let's review each one of them. What is this? That's in the middle. 600. 600 is the intersection of M and H, so it's males with hypertension. 600. 900 males do not have hypertension. If you're outside of the male circle, these two numbers must represent females. These 360 females are in the hypertension circle, so 360 females have hypertension, and 840 females do not have hypertension. All right, the rest of it should be very, very simple. One person is selected at random. What is the probability that the person is male? Well, it's the number in the male circle over the number in the sample space. As simple as that. The probability of, I could have written it like this, I should have. The probability of M is the number in M over the number in S, which would be, how many males? 1,500 over 2,700, which reduces to 15 over 27, and then 3 goes in, 5 over 9. But as I've mentioned on the test, I don't expect you to reduce the fractions. It actually makes it easier for me to grade when you don't. But if you do, it's absolutely perfectly fine to reduce them. Part B, what's the probability the person has hypertension? Well, because we've done all this work, it's trivial. The probability of H is the number of elements in H over the number of elements in the sample space. H has 960. And the number in the sample space is 2,700. What is the probability that the person has hypertension given that the person is male? So since we have the diagram, this is very simple. By the formula, it would be it'd be the number of elements. I could have used probability if I wanted to, because it's a fraction. It's a number of elements in, let's see. Let me write it down here. It's the probability of H given M, right? Given that the person is male. Well, by the formula, that's just the number of elements in H intersect M over the number of elements in M. And we'll find out what that is. Very simple, because we actually didn't necessarily have to use that formula. Given the person is male means that we're dealing only with this circle here. That's it. That's the whole universe we're dealing with now, with only those 1,500 people. How many of those people have hypertension? 600. So 600 out of the 1,500. And this happens to be the number of elements in H intersect M, 600, over the number of elements in the male set, that circle, has 1,500. Okay, what's the probability that the person has hypertension? So it's the probability of H given, I could use F, but I'm going to use M complement, not male, to mean female. Okay, I don't have F up here, so if you're not in the M circle, you're in F. You're in the female circle. You're not if you're not in M. Everything else outside of the M is female. So this is going to be the number of elements in H intersected with M complement over the number of elements in M complement. Well, M complement is easy. It's the number of women, right? Female, we could look up there, it's 1,200. You can also look at it as outside of the male circle is 360 and 840, which adds up to 1,200. That's a denominator. That's the number of females. Which region is hypertension intersected with not male? That means you're in the hypertension circle, but you're not in the male portion of it, so it'd be 360. All right, two more. Two more to go. All right, we still see the diagram up here. So part E, what's the probability that the person is male if you know that the person selected is selected from persons with hypertension? So that's the probability that the person is male given what? The person has hypertension. That's equal to the number of elements in M intersect H over the number of elements in H. Intersect them on top, take the second one, put it on the bottom, the number of elements in those sets. How many elements are in M intersect H? That's 600. That's that right there. How many elements are in the H circle? 960. And let's look at that again another way. If you know the person was selected with hypertension, you're in that circle. That's like your universal set. How many of those people have hypertension out of the 960? 600 of them have hypertension because they're in the, I'm sorry, let me see. Given they have hypertension, oh, we're looking for the probability of male. Given you're in this circle, the 600 are in the male circle, the 360 are the females. So 600 of the hypertension people are male, and that's what we're looking for. Last one. Probability that the person is female, probability of F, if you know that the person is selected from those without hypertension. So, oops, I'm going to start over. The person is female, I'm going to put M complement. M complement, not male, means female. Given, you know the person selected from those without hypertension means given H complement. You're not in the H circle. All right, so by the formula, this is the number of elements in M complement intersect H complement over the number of elements in H complement. So what section is M complement intersected with H complement? So it's the region that is not in the M circle and not in the H circle. That's everything that's not in either of the circles. That's this number, 840. And then how many are in the complement of H? Well, here's H. How many are outside of the circle H? 900 and 840, which is 1740. And looking at it another way, the probability of M complement given H complement. Given that H did not occur means you are not in the H circle. Okay, so we're only dealing with this and the outside, complete outside, this 900 and the 840. So given that, what's the probability you're not male? You're not in the M circle. Well, you're not would be this, 840 over the sum of those two numbers. So we get the same result using the formula or just using that diagram.